Humans like to believe we understand the universe. For most of history, our everyday experience seemed to confirm that belief. The ground beneath our feet felt stable. The sun appeared to circle the earth. Living creatures seemed carefully designed. Cause led to effect in predictable ways. Yet, again and again, science has delivered unsettling news. Earth is not the center of the universe. Humans were not specially created. Time itself does not flow equally for everyone. The universe had a beginning. And at the smallest scales of reality, even causality appears to blur into probability. Scientific progress is therefore not merely the accumulation of knowledge, it is also the painful abandonment of deeply rooted intuitions and beliefs. Throughout history, some discoveries have been far more difficult to accept than others. Certain ideas struck directly at human pride, common sense, or long-standing philosophical assumptions. They forced people not simply to learn something new, but to reinterpret their place in reality. This episode explores 5 scientific concepts that have proven particularly difficult for humanity to accept. The ranking is not based solely on scientific importance, but on the psychological and cultural resistance these ideas provoked. 3 criteria guide the selection. First, the depth of impact. How profoundly did the idea challenge humanity's worldview, religious assumptions, or sense of specialness? Second, time required for acceptance. How long did debate persist before the idea gained widespread acceptance and thus resistance still remain? Third, conflict with everyday intuition. How strongly does the concept contradict the way the world appears to us in ordinary experience? Taken together, these criteria highlight discoveries that forced humanity to rethink not only the universe but itself. The ranking begins with the concept that struck most directly at human identity and moves toward increasingly abstract challenges to our understanding of reality. The scientific idea that proved hardest for humans to accept is the theory of evolution proposed by Charles Darwin in On the Origin of Species. The reason is straightforward. Evolution delivers a profoundly uncomfortable message. Humans are not uniquely created beings standing apart from nature. We are the result of the same natural processes that produced every other organism on Earth. According to evolution by natural selection, all living species share common ancestry. Over immense spans of time, small variations accumulate, and those best suited to their environments survive and reproduce. This idea struck directly at human self-image. Many religious traditions had long taught that humans occupied a special place in creation. Evolution replaced that narrative with a far less flattering one. Humans are biologically related to other animals, sharing deep ancestry with creatures that crawl, swim, and fly. The impact was explosive. Darwin's work triggered intense debate across Europe and America. The famous 1860 confrontation at Oxford between defenders of Darwin and critics aligned with religious authority symbolized the broader cultural shock. Even decades later, the controversy continued to surface, most famously during the Scopes monkey trial in Tennessee in 1925. More than a century and a half after Darwin's publication, the debate has not entirely disappeared. In some educational systems and religious communities, disputes over evolution and creationism persist even today. Among the ideas on this list, evolution remains unique in the depth of its challenge to human identity. Unlike cosmological discoveries that concern distant galaxies or abstract physical laws, evolution tells us something intimate and unsettling. The story of life on Earth includes us, but it does not revolve around us. For that reason, evolution occupies the first place in this ranking. The second most difficult concept for humanity to accept was the realization that Earth is not the center of the universe. For centuries, the dominant cosmological system was the geocentric model developed by Claudius Ptolemy. In this model, Earth sat immobile at the center of the cosmos while the sun, planets, and stars revolved around it. The idea seemed perfectly consistent with everyday experience. The ground beneath our feet feels still. The sun appears to rise in the east and set in the west. Nothing in ordinary observation suggests that Earth itself is moving. In 1543, however, Nicholas Copernicus proposed a radical alternative, the heliocentric model, in which Earth and the other planets orbit the sun. For decades, this idea remained largely theoretical. The decisive shift came in 1610 when Galileo Galilei turned the newly improved telescope toward the sky. What he saw fundamentally changed humanity's understanding of the universe. While observing the planet Jupiter, Galileo noticed 4 tiny points of light near the planet. Night after night, he tracked their motion and realized something astonishing. These small bodies were orbiting Jupiter itself. Today, they are known as the Galilean moons. This discovery carried profound implications. According to the geocentric doctrine, all celestial bodies were supposed to revolve around Earth. Yet here was a clear evidence that some objects orbited another planet. Earth was no longer the unique center of motion in the universe. Galileo soon made another crucial observation. When he carefully observed the planet Venus over many months, he discovered that Venus changed shape in the sky, displaying a full range of phases similar to the Moon, from thin crescent to nearly full illumination. This behavior could not be explained within the traditional Ptolemaic system. In the geocentric model, Venus always remained between Earth and the Sun, meaning it should only display crescent phases. But if Venus orbited the Sun, as Copernicus proposed, then all phases, from crescent to full, would naturally appear depending on its position relative to Earth. Galileo's observations revealed exactly those phases. For the first time, direct astronomical evidence strongly supported the heliocentric model. The implications were staggering. If Earth was merely one planet orbiting the Sun, then humanity no longer occupied the center of the cosmos. What had once seemed obvious, and the universe revolved around us, turned out to be an illusion created by our limited perspective. The third concept on this list challenges something even more fundamental than our cosmic position, our understanding of time and space themselves. In 1905, Albert Einstein introduced the special theory of relativity, followed a decade later by general relativity. Together, these theories overturned centuries of Newtonian assumptions. Under classical physics, time flowed uniformly throughout the universe. The space provided a fixed stage on which events occurred. Relativity revealed a very different reality. Time can pass at different rates depending on motion and gravity. Space itself can bend and curve in the presence of mass and energy. One of the most famous thought experiments illustrating this idea is the twin paradox. If one twin travels through space at extremely high speed and later returns to Earth, that twin will have aged less than the sibling who remained behind. Such conclusions defy ordinary intuition. Nothing in daily life prepares us for this idea that time itself is flexible. Although the scientific community accepted relativity relatively quickly, especially after observations during a 1919 solar eclipse confirmed Einstein's predictions, the theory remains difficult for the public to grasp intuitively. Relativity does not challenge human pride in the same way evolution or heliocentrism did. Instead, it undermines something even more basic, the assumption that the universe operates according to simple intuitive rules accessible to everyday experience. For much of human history, philosophers assumed that the universe was eternal. From the time of Aristotle onward, many thinkers believed the cosmos had always existed and would continue forever. This assumption began to collapse in the 20th century. In 1927, the Belgian physicist and priest Georges Lemaître proposed that the universe had expanded from an extremely hot and dense early state. Soon afterward, astronomical observations by Edwin Hubble revealed that distant galaxies are moving away from one another, indicating that the universe itself is expanding. These discoveries led to what is now known as the Big Bang Theory. The phrase Big Bang, ironically, was originally coined as a term of ridicule by critics who doubted the idea. Over time, however, accumulating evidence strengthened the model. The discovery of the cosmic microwave background radiation in 1965 provided powerful confirmation that the universe had once been far hotter and denser. The Big Bang does not necessarily imply that the universe emerged literally from nothing, since the laws of physics become uncertain at extremely early times. What it does indicate is that the observable universe evolved from a specific beginning roughly 13.8 billion years ago. This realization introduced a profound philosophical shift. If the universe had a beginning, then it is not eternal. It has a history and perhaps someday an end. Finally, we arrive at perhaps the most intellectually unsettling concept of all, quantum mechanics. In the early 20th century, physicists studying atoms discovered that classical physics could not explain the behavior of matter at very small scales. New theories emerged from scientists such as Werner Heisenberg and Niels Bohr. One of the most famous principles of quantum physics is Heisenberg's uncertainty principle, which states that the position and momentum of a particle cannot both be known with perfect precision at the same time. More broadly, quantum theory suggests that physical systems are fundamentally probabilistic. Instead of predicting exact outcomes, the theory describes probabilities. This shift from certainty to probability deeply disturbed many scientists. Even Albert Einstein famously objected, remarking that God does not play dice. Quantum mechanics also introduced phenomena such as entanglement, in which particles separated by vast distances appear to share correlated properties. Despite these strange implications, quantum theory has been confirmed by countless experiments and forms the foundation of modern technologies, including semiconductors, lasers, and emerging quantum computers. Yet, psychologically, it remains difficult to accept. A universe governed by probabilities rather than strict causality contradicts one of humanity's most basic expectations, that every event must have a definite cause. These 5 ideas share a common pattern, each stripped away a layer of human certainty. Heliocentrism revealed that the Earth is not the center of the universe. Evolution showed that humans are not uniquely created beings. Relativity demonstrated that time and space are not absolute. The Big Bang revealed that the universe itself has a history. Quantum mechanics suggests that reality may be fundamentally probabilistic. Taken together, they form a sequence of intellectual shocks that gradually reshaped humanity's understanding of existence. The history of science repeatedly shows that the most important discoveries are often the ones that feel most uncomfortable at first. Humans naturally seek certainty, stability, and a sense of specialness. Scientific truth rarely grants those comforts. Instead, it asks us to abandon familiar beliefs and accept a universe far stranger than intuition would suggest. Yet, that discomfort is precisely what drives discovery forward. The story of science is therefore not only a triumph of knowledge, it is also a testament to humanity's willingness, however reluctantly, to confront truths that challenge the very foundations of how we see ourselves and the cosmos. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.